Okay, let's do another example of balancing half reactions in acidic environments. So in a prior video, we went over the steps of how to go about doing that we need to assign the oxidation numbers. We're going to split and balance our half reactions, kind of going through this step now that we know we're in an aqueous environment and an acidic environment. And then we can kind of balance out the charges by adding electrons, and then we put it all together, and voila, we've balanced a half reaction in an acidic environment. So let's look at another example. Let's take this one with iodine and nitrate. So our first step is to assign the oxidation numbers and to identify who's being oxidized and who's being reduced. Well, iodine is in its elemental form. It's diatomic, so it is going to be an oxidation state of 0. Now nitrate is going to be, the -2 is always true for oxygen, so oxygen in a compound is always a -2. -2 times the 3 is -6. What plus -6 gives me a -1 charge? That would be +5 for nitrate. Iodate here, so has the same kind of pattern. So we have a -2 for our oxygen, right? And so 3 times my -2 is -6. What plus -6 is -1? Well, that's +5 as well. And then this is nitrogen dioxide, no charge on it. So my oxygen here is -2 because it's oxygen in a compound. -2 times my 2 is -4. So to balance out a -4, I need a +4. All right, so I've assigned oxidation numbers. So now I need to figure out what's being oxidized and what's being reduced. It looks like my iodine is going from 0 on my reactant side to +5 on my product side. So my oxidation half reaction is going to just focus on my iodine. So I'm going from I2 to iodate. And again, I'm keeping all the component pieces here, because now our next step when we're balancing the half reaction is to balance every element except for oxygen and hydrogen. In this case, I have 2 iodines on one side, 1 on the other, so I need to have 2 of these guys. Okay, that's step 1. Step 2 is to balance out the oxygens by adding waters. We're in an aqueous environment, so I can add as much as I want. On this side, I now have 6 oxygens, so I need to add 6 waters to this side. My next step is to balance out the hydrogens by adding H+ to both sides, which I can do because it's in an acidic environment. So I have 12 hydrogens on this side. So I need 12 H+ on this side. And now I need to think about electrons. If I look at the net charge on this side, there's no net charge, right? They're both neutral compounds. So I have 0 net charge on this side. If I look at this side, I have a -2 here, so 2 times my -1, and a 12 times my +1 gives me a +12. So my whole net charge here is going to be a +10. So in order to get rid of that +10, or at least to balance it out with the 0 on the other side, I need to add 10 electrons to this guy. So here is my new half reaction that shows that oxidation step. Okay, so far so good. Now we need to figure out what's being reduced. So if we look at our overall reaction, it looks like oxygen is staying the same. Iodine was what was being oxidized. So if I look at my nitrogen, I'm going from a +5 to a +4. So I'm reducing my oxidation number, which is reduction. So that's going to be my nitrogen. So we're going to keep all the things. Here's the nitrate going to nitrogen dioxide. Now our first step again is to balance all of the elements except for oxygen and hydrogen. So that would be our nitrogen. It's 1 and 1, so we're already good to go. So that's a good step. Now our next step is to add the oxygens to balance out those. I have 3 on one side but only 2 on the other, so I need to add a water to this side to give me more oxygen. Now I have 3 total. Now my next step is to balance the hydrogens by adding H+ to both sides. I have 2 hydrogens on this side, so I need 2 H+ on this side. And now I need to make sure that my charges are balanced out. So if we check out what's going on my reactant side, I have a 2+ here and a -1 here. So that means I have a net +1 charge here. And then on this side, I have a net 0 charge because this is a neutral compound, as is water. So in order to balance out these charges, I need to add 1 electron to this side. Now again, a couple of quick steps to make sure that you know you're doing this okay. If you're not adding electrons to the product side here, then it's not really oxidation, right? Oxidation is loss of electrons. If you're not adding electrons to the reactant side here, it's not really reduction. Reduction is gaining electrons. Now we need to combine these guys together and simplify them, but in order to do so, we need to make sure that these electrons balance out. So the same number of electrons that I lose in my oxidation step should be the same number that I gain here. So what that's going to mean is that I need to multiply my entire second reaction here, my entire reduction half reaction, by 10 in order to balance out those 10 electrons that we're losing, because they have to go somewhere, and only one of them is going to get picked up per this reaction. All right, so let's rewrite just for clarity's sake here. So we have 6 waters and my iodine going to my 2 iodates, 12, 10. We're going to add to it 10, 20, 10, 10. Okay, now we know that we can add together reactions. We've been doing that. So we add together everything that's on our reactant side, everything that's on our product side, and then we can combine and simplify terms once we've added them together. So let's get it all in one place, and then we'll go back and forth for clarity's sake. That's a 10. That's a 20. That's a 10. Make sure to clarify my zeros versus my oxygens here. It's always tricky for us chemists, you know. All the symbols look the same. I was talking to a mathematician today who said the same thing for mathematicians. Okay. All right, so what can we get rid of? Well, we can get rid of the things that are the same on both sides, so we can for sure get rid of my electrons. And what else can we get rid of? Well, I have 12 hydrogens on this side and 20 hydrogens on this side, so I can get rid of 12 of these, and that leaves me 8. I have 10 waters on this side and 6 waters on this side, so I can get rid of 6 on each side, and that leaves me with 4. Okay, that looks pretty good. Now, if I kind of figure out what I have left over then, so here's my overall. Then I have my iodine, 8 hydrogens, 10 nitrates, 2 iodates. Got rid of those, got rid of those. 10 of my nitrogen dioxide. And 4 waters. Okay. Now, to check to make sure that this stands up, which again, it's the nice thing about redox processes, it's the nice thing about balancing them in either acidic or basic environments, is we can always check to make sure that our answer makes sense. We need to have the same number and type of thing on each side. So we're making sure that we have the same number and type. So that's a lot of oxygens. Yeah, okay, so I have the same number and type of element on each side. And now, charge-wise, I have 8 plus here, 10 minus, and then I have 2 minus here, and that's it. So that means I have a net 2 minus charge on both sides, so I'm good to go as well. So here's my overall reaction, and that would be my final answer of balancing this redox process in an acidic environment. So this is just another example. It's kind of a follow-up to my first video on balancing redox reactions or balancing half reactions in acidic environments. And I will talk to you again soon about doing this in a basic environment.